Welcome to our explainer of the brand new Stanford HAI 2026 AI Index Report. Let's just jump right in, because what we're witnessing right now is truly an unprecedented mass adoption of artificial intelligence. We're way past the initial hype cycle at this point. We're looking at a landscape where this tech is literally arriving everywhere, reshaping how we learn, how we work, and how we govern ourselves. But as you'll see, the most fascinating story here isn't just about how fast AI is growing. It's about what happens when it completely outpaces the world around it. Right off the bat, listen to this quote from the report's co-chairs, Yolanda Gill and Raymond Perrault. They hit the nail on the head. This idea perfectly captures the central paradox we're unpacking today. Basically, as these AI models get bigger and smarter, the systems we rely on, our laws, our testing benchmarks, our schools, they're fundamentally struggling to keep up. It's a massive scaling gap. Want to know why those systems are straining? Just look at the sheer speed of it all. 53%. That is the population-level adoption generative AI hit in just 3 short years. To put that into perspective, this tech achieved mass adoption way faster than the personal computer and even faster than the internet. People are getting real value out of these tools, and organizational adoption has surged to 88%. It's just everywhere, almost overnight. Okay, moving into Section 1, the geopolitical board, convergence and concentration. Let's zoom out to the global stage and see how this rapid scaling is driving some really intense international competition.
It's absolutely wild how much the playing field has leveled recently. The historical performance gap between the US and China, it's effectively gone. Over the last year, these top-tier frontier models have just been trading the global lead back and forth. In early 2025, China's DeepSeek R1 briefly caught up to the top US models. And based on this report's data, Anthropic's top US model is holding onto the lead by a razor-thin margin of just 2.7%. The technical frontier is converging incredibly fast.
But hey, while the algorithms might be neck and neck, the physical infrastructure is a totally different story. The US currently boasts a mind-blowing 5,427 AI data centers. That's more than 10 times the amount of any other single country on Earth. It just brilliantly illustrates the sheer physical footprint and the massive piles of cash required to even stay in this race. But here's the catch, and it's a massive choke point. Practically all the leading AI chips that power those thousands of data centers, they're made by one single company, TSMC. That concentrates the entire global hardware supply chain on one foundry in Taiwan. Now, a TSMC US expansion did begin operations in 2025, but for now, the world's AI ambitions are completely tethered to this highly fragile bottleneck. All right, Section 2, the jagged capabilities frontier, brilliant but broken. We've seen the hardware scale, but what can these systems actually do? Well, this is where it gets kind of bizarre. We're looking at a wildly uneven intelligence profile. On one hand, you have a model like Gemini DeepThink performing so well it can literally win a gold medal at the International Math Olympiad. We're talking top-tier, PhD-level math here. But then, at the exact same time, these incredibly brilliant models will completely fail at a task a first grader can do, like reading a basic analog clock. 50.1%. Just let that sink in for a second. Despite mastering highly abstract math, the absolute smartest models on Earth can only read a standard analog clock correctly about half the time. It's literally a coin toss. This is exactly what we mean by a jagged frontier. Superhuman brilliance is existing right next to glaring elementary failures. And this paradox spills right over into the physical world, too. Take robotics. In a nice, neat, predictable software simulation, robotic arms hit an impressive 89.4% success rate. But toss those same systems into a real kitchen and ask them to do a basic, unpredictable household chore, the success rate totally craters to just 12%. They fail nearly 90% of the time when dealing with real-world chaos. So as we look at this whole AI landscape, really think about how this jagged, unpredictable capability frontier is about to slam headfirst into our daily lives. Which brings us to Section 3, the real-world collision, jobs, medicine, and safety. Let's dive into exactly how these contradictory systems are reshaping some of our most critical fields. Let's start with money and talent. Private AI investment in the US is astronomical, hitting $285.9 billion in 2025. But check out the human side of the equation. The influx of top-tier global AI researchers actually moving to the US has absolutely tanked. It's dropped 89% since 2017, and 80% of that drop happened just last year. So the US is pouring in limitless capital, but losing its gravity for global talent.
And we're seeing the real human cost of all this AI efficiency right now. The report highlights massive productivity gains. We're talking 14 to 26% boosts in fields like customer support and coding. But in that exact same field of software development, entry-level employment for U.S. developers aged 22 to 25 dropped nearly 20% in a single year. We are actively watching junior roles get displaced as AI scales up.
This wild disparity is even showing up in your doctor's office. On the right side, we've got incredible tools like AI scribes saving doctors up to 83% of their time on clinical notes. That's a huge win for physician burnout. But researchers reviewed 500 clinical AI studies and found a massive red flag. Only 5% actually used real patient data for testing. Almost half of them just used medical exam questions.
That lack of robust, real-world testing translates straight into real-world risks. Just look at the numbers. Documented AI safety incidents spiked from 233 last year to 362 in 2025. The capabilities of these models are simply outrunning our responsible AI frameworks. We're deploying them into the wild before we fully understand how they break.
Plus, we absolutely can't ignore the immense physical and environmental toll this takes. Global AI data center power capacity has now hit 29.6 gigawatts. To put that into perspective, that is basically comparable to the peak energy demand for the entire state of New York. The sheer resources, the power, the water required to run these systems are becoming a planetary scale issue. So, with all these massive disruptions happening all at once, from jobs to the power grid, society is naturally having a strong reaction. We're watching a technology advance way faster than our cultural and legal guardrails can handle. And that perfectly sets up our final section, the future divide, trust and optimism. Let's look at how everything we've talked about creates a huge split in how different groups view the future. There's a sheer canyon of a disconnect between the people building this technology and the rest of us living with it. When you ask about AI's impact on jobs, a massive 50-point gap opens up. 73% of AI experts think it's going to have a positive impact, but the general public? Just 23% share that optimism. That is a profound divide in expectations. And you see this public skepticism bleeding right into global governance, too. In the US, only 31% of the public trust their own government to regulate AI effectively. Meanwhile, looking at the global stage, the European Union has somehow emerged as the most trusted entity worldwide to manage this stuff, more trusted than either the US or China. Public trust is just incredibly fractured right now. So this brings us to the ultimate takeaway of our explainer today. We are navigating a massive scaling gap, a world where the tech is simply blowing past our benchmarks, our laws, and our understanding. The crucial question we've all got to ask ourselves as this arrives in our schools and our workplaces is this. Looking at both the superhuman capabilities and the profound risks, are you leaning more toward the anxiety of the public or the optimism of the experts? Thanks for joining us, and keep questioning the data.